Example 1. Find the general solution to the differential equation dy dx equals xy sine x. Now, a differential equation is just an equation that involves a function and then one or more of its derivatives, like dy dx. And when we find a general solution, we want to solve this equation for y, and general solution means that plus c is going to be part of the answer. Plus c being the constant of integration, because we're going to be integrating here. Now, in terms of how you actually solve a differential equation, for something like this, dy dx equals xy sine x, the main method we learn for A-level maths is called separating the variables. And what that means is you want to put all the y's on one side and all the x's on the other. Specifically, you want to move anything to do with y onto the left. So in this case, I'm going to keep the dy on the left, and I'm also going to divide by y on both sides. So I get 1 over y on this side. And then I'm going to leave the x sine x on the right, but I'm also going to move the dx over to the right. You can think about that as multiplying up by the dx if you want. Now, the reason we've done that, we've separated the variables so that we can integrate on both sides. And we can now do that because each side is just in terms of one variable. If we integrate the left, that's just ln y. You'll notice I'm not going to put a plus c on this side, and I'll explain that in a second. Then the right-hand side, to integrate x sine x, that looks like an integration by parts. So on the side, let's do an integration by parts. Integrate x sine x dx. I have made another video on integration by parts where I talk through this LATE acronym for choosing u, so I'd recommend you have a look at that video if you haven't already. Basically, we can use this acronym to prioritize choosing what u should be, and in this case, we've got an algebraic term and a trigonometric term. Algebraic comes first, so I'm going to say that u should be x, and therefore dv dx is going to be sine x. I differentiate u to get 1. I integrate sine x to get minus cos x. And then we apply the integration by parts formula, which gives us minus x cos x minus integral of minus cos x dx. And then when you evaluate that, you get minus x cos x plus sine x plus c. So we can take that answer and put it back over into our main working out. So the right-hand side evaluates to minus x cos x plus sine x plus c. Now I will include the plus c on the right-hand side of this. Didn't put it on the left, but I will put it on the right. And that's because you only really need 1 plus c in a differential equation, and usually we put it on the right. Now that would actually do as a final answer for a general solution because they haven't specified that they want any specific format. But if you wanted to, you could e both sides to get rid of the ln. So you could make it y equals e to the power of that whole thing. Either way is fine. Example 2, find the solution to the differential equation that, given that when y is 0, x is 2, give your answer in the form y equals f of x. Okay, so the difference here compared to example 1 is that we are given some conditions here. Y equals 0, x equals 2. That means that at some point we're going to substitute those in to our solution, and that's going to allow us to find out what plus c is. Also, something to note is that they do specify a form for the final answer, so you do need to make it y equals something at the end. So let's start by writing the differential equation out again. So dy dx equals y plus 1 squared. We're going to separate the variables again. So y is on the left, x is on the right. Means we're going to divide by y plus 1 squared to get the y's over there. And then there isn't actually any x's. So when that happens, you can just put a 1 there, almost like a placeholder. Then we can integrate both sides. Before we integrate, I'd probably just rewrite the left as y plus 1 to the power of minus 2, leave the right as 1, and then integrate that however you like. And you get minus y plus 1 to the power of minus 1. And then on this side, x plus c. Remember, we need the plus c on one of the sides, and usually we put it on the right. Now, you could substitute the conditions in at this stage, but I probably would rewrite this again as minus 1 over y plus 1 equals x plus c. And then I would substitute in the information. So we're told that when y is 0, x is 2, and that was given in the question. So let's substitute that information in, and it'll be minus 1 over 1 equals 2 plus c, which means that c would end up being negative 3. So once again, you're finding plus c using the information given in the question. From here, it's just a case of substituting that c value back in to your equation and then rearranging for y. So you could do this in a few ways, but I'd probably times by minus 1 on both sides, or divide by minus 1, so that we get minus x plus 3. I'd then swap those around. So it's 1 over minus x plus 3 equals y plus 1. And then y equals 1 over minus x plus 3 minus 1 for the final answer, y equals f of x. Last example, a modelling one. A large spherical balloon is deflating. At time t seconds, the balloon has radius r and volume v. The volume of the balloon is modelled as decreasing at a constant rate. Using this model, show that this differential equation is true, where k is a positive constant. And then there's a second part, which gives us some conditions which we can then substitute into our equation. Let's start with the first part though, so showing that that differential equation is true. So we know that we've got a spherical balloon, so the shape that we're working with here is a sphere. We know that the volume of the balloon is decreasing at a constant rate. So straight away from that piece of information, we can say that dv dt must be minus and then any letter you want to show that it's a constant rate. I'm going to choose C. Usually I would choose K, but I've just got an I on the final equation that we want to get to, and that uses K. So best to avoid that for now. Now we want to show that dr dt is equal to something. So I would think about what that is, dr dt. Using the chain rule for differentiation, that can be split into dr over something times something over dt. In terms of what we fill the gaps with, considering we already have something to do with dv dt, it would make sense to fill that with dv. And therefore we know that dr dt is going to be equal to something times minus c. All that's left to do is to find that dr dv. We said that we're working with a sphere, so the volume of a sphere is 4 over 3 pi r cubed. We can easily find dv dr from here, which is 4 pi r squared. And then it's just a case of flipping it upside down and subbing it into that purple equation. So it's going to be 1 over 4 pi r squared times minus c. So the dv dt was minus c, and that we got from just interpreting the words in the question. And then dr dv was 1 over 4 pi r squared because dv dr is 4 pi r squared, and then we just flipped it upside down. Once we have that, we can simplify it a bit by saying that's the same as minus c over 4 pi r squared, which basically looks like the expression that they wanted, but we can make it look even more like that if we change it so that it's minus and then c over 4 pi on the top and r squared on the bottom, because that is minus k over r squared, where k is c over 4 pi. That's it for the first part. For the second part now, we can read the information here. So given that the initial radius of the balloon is 40 and after 5 seconds the radius is 20, the volume of the balloon continues to decrease at a constant rate until the balloon is empty. Solve a differential equation to find a complete equation linking r and t. So we've got that dr dt equals minus k over r squared. If we then separate the variables, so we're going to put the r's on the left, so that's r squared dr, integrate, and then I would keep the constant minus k on the right and just move the dt up, integrate. So that is separating the variables again. When you integrate that, you get a third r cubed equals minus kt plus c, and then you're ready to substitute in the information that was given. So initial radius is 40, means when t equals 0, r is 40. So we sub that information in, we get that c is equal to 64,000 over 3. So the next iteration of the equation is a third r cubed equals minus kt plus 64,000 over 3. Let's put in the next information. So when t is 5, r is 20. Subbing that in is going to allow us to find k. And you get k is 11,200 over 3. So now the equation looks like this. We can times everything by 3. And this is a complete equation linking r and t. But I would probably cube root both sides just to make it r as the subject. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.